colored pens up. Let's see how we're doing with solving multi-step equations and some real-world scenarios. Number 1, you were asked to write an equation and solve it. I would like the equation first. Start with Annie, then David, and then Tristan. Annie, what'd you get?
The equation
Just the equation.
was 120 plus 55w equals 395.
Okay.
120 plus 55x equals 395.
So same thing, different letter. Tristan?
Well, I have the same thing, it's just that I didn't make like something.
So go ahead, read yours.
35b plus 20b plus 120 equals 390.
So that's all the same thing, and in fact, I have mine like Tristan, although the other two were even more advanced because they simplified right away. So 395 equals 120 plus 35x plus 20x. The letter you use doesn't really matter, and you could have the entire right side all the way on the left and the entire left side all the way on the right. And of course, as people said, 35x and 20x is really 55x, so if you simplified that right away, that's great. Now you got a comment about this, or are you going to give me the solution?
Oh no, I wrote something different.
Go ahead.
W equals 395 minus 120 over 55.
Okay. It's not really what I am looking for, but I understand what you did. Annabelle? Solution, go ahead. Annabelle, then Amani, and then Essence. Annabelle, what'd you get?
X equals 5.
Okay.
X equals 5.
Everybody thinks it's 5. It is 5 weeks. So that was working through a real-world scenario. Now some straight-up solving equations. What do we get for number 2? We'll start with Cameron, DeAndre, and then Angela.
-1.
-1.
X equals -1. And now the tough one. What'd you get for number 3? We'll start with Catalina, then we'll go Angela, and then David.
0.75.
Okay?
I got 5.
Okay?
N equals 1.5.
Okay, I got 3 different answers floating around. Anyone want to jump on one of those or introduce a new one? Nali, and then Annie, and then George. Okay?
1.5.
Okay, someone else said that? Okay, so we have some agreement there. The correct answer is 0.75. So, let's go back to number 1, and then I'm going to jump over to number 3. There was something different about number 1 when you compare it with all the other questions we've done that were similar to it. There was one detail that was very different. What was it, Kiara?
It said also need $20 a week walking delivery jobs.
Okay. So why is that different? That sounds just like other questions we've done.
Because there's like 2 rates.
Ah, that was the key right there. That was beautiful the way you said it. 1 rate, 2 rates. But even though there's 2 rates, we're still talking about the same idea and the same person. In fact, you are the character in the story. It says you are saving money, so I didn't put a person's name, I said you. So you're saving money, and you're saving $35 a week mowing lawns, but then you're also, just like Kiara said, also walking a neighbor's dog and making that $20 a week. So how much altogether are you making? $55 a week. So even though there are 2 rates, in actuality, it's really just one big rate. You're really making $55 a week. It doesn't matter how many jobs you do. It's really just how much you make per week. Okay? That is why I wrote it separately, but I was very impressed with my students who wrote it all as one, 55x. Are there any comments or questions about number 1? Yes, and then yes.
I did the equation right, but then when it got to the part about trying to do the 35x and the 20x, I actually did it and it was 55x, but I didn't know what to do because I got 2 different variables, so I didn't know what to do.
Okay, so that's the key, is it's not two different variables. It's the same. Because even though it's still, look at what it says, a week. If it said something different, like if it said a month, then that would be a more difficult situation. But they're both happening each week. So all we have to do is count how many weeks it's going to take, okay? But I'm glad you brought that up. That is an important detail. Essence and then George?
What I had to do for number 1, I had to like literally give the problem like numbers.
Yeah, well, that's because it's hard. Yeah.
So, I did like the problem.
Okay.
The first time I added 120 plus, like, because the first time I didn't add the 20 times a week.
Okay.
Because I didn't really pay attention to that.
Okay.
I added 120 plus 20, I got 140. And then I realized that's not even possible answer, so I did I did 35 W plus 120. But then I didn't do that because it was
Okay.
So then the last one I did 35 W plus 20 W because I read the problem over.
Okay. That's great. And I love the way you talked us through your thought process. That was excellent. Very good job. I feel like I missed someone. I think George was there.
At first I did it right, I subtracted 20, but then I forgot to add the 20 W and 35 W, so I was like, oh, hold on, I'm doing something wrong. So then I added the 140, and that's when I got 55 instead of 5, and that's why I got 9. So like, messed up. I did it right at first, but then I did it wrong.
Okay. So what ended up being the mistake?
At first I subtracted 120, but then I started crossing over, and then I added 120. So
Oh, okay. But you had the 35x and the 20x?
yeah,
Okay.
at first, and then I added.
Okay, good. Tristan?
I don't understand. Number 2. I get to the third part.
Okay, well I'm gonna go from number 1. I'm gonna go to number 3, and then I'm gonna work with you individually on number 2. Okay? So let's go to number 3, and first I'm gonna survey the class. Give me a thumbs up if you got number 3 correct. Yeah, I know of one person who got it correct. Good, put your thumbs down. So this is gonna lead us into today. This is a type of question you're gonna be seeing today. So let me change it to see if that opens your eyes a little bit, and I've done this before. So everyone's got their colored pen and everyone's looking up here. What if I took that away? Would that simplify it for you in your mind? Okay, so what is this an example of that we see here now that I've whited out part of it? Tatiana? Distributive property. But there's a key part of it. There's a couple of things. There's this here, and then there's this. So there's a number of different ways we've talked about dealing with these negatives. So let me show you what my thought process is. I see this as a -2 being distributed here and here. But I'll take it a step further. I see this as a positive 3n, and I see this as a -15. That's the way I see it. I think at some point you either already see it that way, or at some point soon you're going to need to start seeing things that way. That's why we use the bubble method, so you can see that as a -15. So now distribute. -2 times 3n is -6n. -2 times -15 is positive 30. We didn't use the equal sign and we didn't use the 60. So now this is my equation. But watch. I whited out the part that was confusing me. We didn't use that yet. So now this comes down here. So now, this you should be very familiar with because it's the same thing that we just did here. 35x and 20x. What was it called when we put those two together? What was that phrase? Someone raise their hand and remind us. What's that phrase when we put those together? Combining like terms. So where are the like terms in number 3 now? Where are the like terms? Catalina?
46n and negative 6n.
I love the way you said that. 46n and negative 6n. When we combine those, what do we get? Kiara? 40n. Very good. And so we end up with 40n plus 30 equals 60. Yep, that's not a 6. 60. How many steps do I have left to solve this complicated equation? How many steps, Stephen? 2. I don't even need to do them. You should be so good at it at this point that I don't even need to do the steps. You know that you draw your t, subtract the 30, divide by the 40. It's almost the same thing every time, so it should be getting very, very quick for you. Okay? So what was the new part? The new part was this whole thing right here. This with this looks very confusing. So here's the rule. You distribute first. Distribute first. You always distribute before doing anything else. So now you have to be like a private eye. You have to be searching for distributive property. Is there anywhere distributive property? If there is, gotta do that first. If not, then move on. Comments, questions? George, we'll start with you.
At first, I did exactly what I was supposed to do, but my mind erased the negative.
The negative in front of the 2?
And then
Yeah.
I had to distribute it.
And so, guess what? The mind is funny that way because the mind takes things that are complicated and says, I don't like complicated, I'm going to make it easy. And so your mind, well, I love the way he said that. He erased it for him. But he's got to untrain his brain to do that. He's got to see complex things as the complex things they are and deal with it properly. Okay? Nolly and then David and then Annie.
When I was doing the problem, I was doing it right. Like I did it with 40n plus 30 equals 60. Wait, no, not the 65, but 40n plus 30. And then I was like, equals. And then I was like, never mind. So I just changed the whole problem.
Because it didn't come out perfect. It didn't come out to a whole number is my guess.
Yeah, so I just was like, that's wrong.
Right, and so that's another thing that the brain does is like, okay, well, I'm used to my homework and my classwork. Everything usually comes out to a friendly number. This one didn't come out friendly, so something must be wrong. And you know what? Sometimes that's correct, but sometimes it's not. And as we move through this year into next year, you're going to be dealing with fractions and decimals a lot. Not even just a little bit, a lot. And so you're going to have to start developing a higher confidence level in just understanding that if you did the process correctly, then you probably did it. David, Annie, Catalina, and then Kiara.
I had the equation and everything. I just didn't finish, so what I did was I had the equation, but I had 0.75 first, but I multiplied it. That was sort of hard.
Okay. Well, I appreciate that you don't feel great about the result, but it sounds like you were on the right track, so that's good. Okay, Annie?
I added the 46n and 3n, and then 2 and 15, and then I subtracted it.
Okay. And that's what I was thinking that a lot of my students were going to do. Listen to what she did. She did the 46n plus the 3n, and then she added the negative 2 and the negative 15, and then worked from there. And that's a good thought. But the problem is that when you have this situation right here, these terms are linked together and you can't separate them like that. Okay? You can only use commutative property and associative property if everything's just being added together. Distributive property, we have this multiplication. That changed everything, okay? Good. Catalina and then there's Kiara. Go ahead, Catalina.
At first, like Nolly, I thought 0.75 was wrong, but then I checked and put 0.75 in, and then I found out it was correct.
Good. That's the key, is that you get an answer you're not sure about, but you can tell if you got it right. You plug it in here and here and chug it out, and you'll know if you got it right. I've been telling you that for a couple weeks now. Is you'll know if you got the right answer. That was brilliant. Kiara.
When I got to like part in the 6 and 30, I was confused because I wasn't sure if I was doing
That's okay. Well, and this is, and I don't mind that at all. You just weren't sure of yourself because we haven't done this type of question yet. But try not to be afraid. Try to take what you've learned and experiment with something new. Okay? Good. You guys are doing a phenomenal job so far, so keep up the good work. Put this warm-up. Today is day 2, so we are continuing the same concept into a second day. Normally on day 2, I do a special activity or maybe 2 special activities that are designed to help you develop your abilities with the same idea. But before I get to today's activity, there are a couple of higher level questions, types of questions that we didn't go over yet. That was done on purpose because the work we're doing is pretty high level in and of itself. So we're going to first go over a couple of examples. One of them is actually the example I started the last lesson with. You might remember that I put up a question, it said example 5, and there was this whole paragraph, and I asked you guys to read it, and most of you were like, what? And then, so today we're going to actually do that question. But we're going to address another one first that I want to make sure we're clear on. Because there seem to be some slight issues with questions revolving around the idea of perimeter. So, we're going to start with this example. We're asked to find the value of x. Now, something Savannah said earlier sparks a thought in my mind. She talked about different variables versus the same variable. When we have an x and an x and an x, we have 5 different x's here. But the value of x is the same for all of them. In other words, another way to say it is this. Look at this x and this x. This distance is the same as this distance. They are equal to each other. So the value of x is the same no matter where it is. Okay? So these are not different variables. They're different instances of the same variable. Okay? So, to figure out what to do, we have to read carefully and understand terminology. So we've already done a few examples that involved perimeter. But when we hear, when we hear the word perimeter, what math operation are we supposed to be thinking of? Angela? Addition. It's a weird thing in our world, even with adults, that for some reason, ideas of distance, people get confused about. Perimeter is a distance around a shape. But let me give you a different example. The distance from my projector to the first desk is 3 feet. The distance from the first desk to the last desk is 12 feet. So the distance from here to here is 3. The distance from here to there is 12. What's the total distance? What's the total distance? Amani? How'd you do that? Yeah, you just add it. So a total distance is just the pieces of the distance, right? So then when you start using the word perimeter, all of a sudden people start going bonkers. Like, okay, perimeter, I guess it's kind of like around, but how do I do that? Well, it's still a distance. It's still the distance from that corner of my room to that corner, and then that corner to that corner. So how would we total that up? Add them, just like Amani said, you add them. So it's the same idea. So first of all, we've got perimeter, so we're going to add up the different distances. What type of shape are we looking at here in this example? What is this? DeAndre?
A pentagon.
Pentagon? How many sides does a pentagon have, Cameron?
5.
5. Are you sure?
Yes. No. Yes.
Yes, no, yes? Yes, you're sure, because of course, a pentagon has 5 sides. I can count them. 1, 2, 3, 4, 5. So there are 5 sides. I was just messing with you. You were perfect. What does the prefix penta mean? Someone raise their hand and tell us. What does penta mean? Stephen? It means 5. So you can use that prefix for other things as well. So now, if I want to find the missing value, and I know the total distance, and I know how to add, then we just write it all out. So now you're going to be writing along with me. It's a total distance, so it actually doesn't matter what corner you start on. So let's just start right here and work our way around. So this distance is x. Then from here to here is 2x minus 1.5. Now I'm here. Now I got to go this distance plus 2x minus 1.5. Now I have to go here plus x, and then here, back to the beginning, plus x plus 7.2, and all together that has to add up to 38.5. That looks like an absolute mess. But if you think back to when I was talking to you about multi-step equations, I said that multi-step equations are just 2-step equations that are hidden. So this looks like a mess, but it's actually something very simple hidden in a mess. So now I'm going to pick a highlighter color, and I need a volunteer to tell me what to highlight. What should I highlight? I didn't even use the word yet. What should I highlight? What should I highlight, Savannah?
All the like terms.
Good. Give me some.
2x, the other 2x, and all the other x's.
Oh, I love the way you said that. How casually she said, and the x's and all the other x's. Those are all like terms. Add them together, what do we get? Essence? You get 7x, and so this complicated mess is really just 7x. And now I'm going to switch colors. Give me something else to highlight. What else could I highlight, Tristan?
Highlight the terms. Not the right term. Other term.
Good. The negative 1.5 and?
Those are like terms.
I don't know. You tell me what else to highlight.
Okay, and then negative 1.5.
Good.
Then positive 7.2.
Yeah, those are all like terms. They're numbers, but they're all called like terms. And so negative 1.5 and negative 1.5, that's easy. And then add on to 7.2. What do I end up with when I add those all together? David? 4.2. So we got 7x plus 4.2 equals 38.5.
What about
7.2.
7x plus 4.2 equals 38.5. So this big mess in one step turned into something that should look very familiar to you. How many steps do we have left to solve this complicated scenario? 2. So there's 2 steps left. We don't even have to do them because we know exactly what to do. Does anyone have any questions on how we got from the picture to here, or how we got from here to here? Any questions? Okay, so now we're going to go to the real work of the day, the example I started with last time. You do not have to copy the text. You need to read the text, but then when I start writing, we're going to be writing at the same time. So go ahead and take 30 seconds to read to yourself. So far this year, I've introduced to you and we've worked through all sorts of different real-world scenarios. For example, in the warm-up, real-world example. Now, if you were, I don't know, you had your first job and you were saving money and you had a situation like this where you were mowing lawns and walking neighbor's dog maybe a couple years from now, and you were saving for the new Xbox. I don't know if you would sit down and write an equation to try and figure out how many weeks it would take, but if you were truly trying to learn how to be an adult, and you were truly trying to learn how to meet goals, then you would set yourself a goal, you would figure out how much money you were making, and you would figure out how long it would take you. So this is a real-world scenario, and it applies to real life. Same thing with a couple of the questions in the homework. And even though this is a little bit different, you will have situations in your life, like when you own a home, where geometry concepts and missing numbers is going to come into play. So this is also a real-world scenario. This question is a little bit different. This is a type of question that we do in math class, and in science classes maybe, and maybe in a class where you were studying logic. But beyond the classroom, it doesn't really have that much application. But it is very, very powerful for figuring out how to work through some things logically. So we are doing this question, and it's different though, and so we need a different approach. So, our normal key of information won't work because it's not a real-world scenario. I can't write total, and then rate, and then flat fee, and then what's missing. Because there is no flat fee, and there is no rate, because it's like this bizarre math situation. But there is a total. What's the total in this scenario? What's the total? Catalina? 39. It says the sum is 39, and sum is another way to say total. So we do have that. But here's where things completely change. Instead of writing down flat fee and rate and what's missing, we are going to write down the three different numbers because we're looking for three numbers. So we are looking for the first number, we're looking for the second number, and we're looking for the third number. They're all missing. But we have some information about each one of them. The second sentence says, let x be the first number. So we use a key to define things. The total is defined as 39. The first number is defined as x. That's told to us right there in the second sentence. Let x be the first number. But then it gets harder from there. The second number is 5 more than the first. The second number, this, is 5 more than the first. Well, you learned how to translate that. What does that translate into? Chelsea?
It's not like x plus 5.
That's exactly what it is. It is x plus 5. It's whatever is here plus 5. So right now an x is here, so that means this is x plus 5. We still have not defined the third number. It says the third number is 2 times the second number. So how do I represent that? Annabelle?
5x.
Okay, 2 times 5x. I know why you said that. So 2 times is definitely going to come into play.
Wait, 2 times x plus 5.
Okay, 2 times x plus 5. But now I got to make sure I write things correctly. This wasn't hard to write, and this wasn't hard to write. But this is not simple to write. Is that the correct way to write it?
Yeah.
Oh, we got some quick responses. Cameron?
2x plus 5.
2x plus 5. Well, that's what I wrote. 2 times x plus 5. So you're saying that it would be correct if I took that out of there?
Yes.
Okay. So let's start with that. Give me a thumbs up if you agree with Cameron that that's the right way to write it. We got some people who think that is and some people who don't. Okay. You don't, Fancy. What's wrong with it?
Wait, I do agree.
Oh, you do agree. Did you put your thumb up? Thank you for that awesome delayed response. Okay, so there were some other people who didn't agree. Now I forgot them. Savannah and then Kiara.
I think you should put 5x times 2 because you don't know the value of the thing.
You're right. We don't know the value of it. Absolutely. So that does play into it. Kiara?
Like it said x plus 5 first, so I think that x plus 5 times 2 would be more easy.
Okay, so you think the 2 should go. You think I should put the 2 over here somehow?
Yes.
So should I just put it like that?
No.
You gotta put the dot.
So then I gotta put the dot back here.
Yeah.
Yes.
Okay, Annie?
Okay, so what it you didn't get the same answer he did what Savannah did because it's there it's x plus 5, but she's saying x times 5.
Okay. So what, you think it's supposed to be x times 5 or no?
No.
No, okay. So I don't know if Savannah was trying to say to multiply or you just got confused for a second.
Oh no, I was just saying that it should go
On the other side. Okay, that's what I thought. Okay. Catalina?
I think you just should put 10 plus x.
10 plus x.
Yeah.
Okay. Well, I'll tell you what. We are missing something. We're missing something really, really important because if I put the x here, I am only multiplying it by the 5. I am not multiplying it by everything. And if I put the 2 over here, I'm only multiplying the 2 times the x. I'm not multiplying it by everything. How can I get the 2 to multiply times everything? Kiara's got the big light bulb going off. Go ahead.
Distributed.
Yeah. This is exactly what we use distributive property for. This is supposed to be 2 times the quantity x plus 5. And that's the way it has to be. How do you know? Because this whole thing is the second number. You can't multiply 2 times part of it. You have to multiply 2 times the whole thing. So, now we have all the pieces defined. Now we go back to the beginning. It says the sum of 3 numbers. So here are the 3 numbers. We need to sum them up. And so now we can simply do what we've been doing in the past. The first number plus the second number plus the third number all has to add up to 39.
Oh, what is that?
And so this is the first number, the second number, and the third number. So now we have a situation similar to what we had a moment ago, which was we have a mess, but you should know already that it's not really a mess. It's a mess that's going to work itself out very quickly. But this one's a little bit different. What's different about this one compared to the ones we've done so far today? Annie?
That you're going to use this distributive property of the
That's right. And when do we do that? Should we do it at the end? Should we do it at the beginning? Should we do it in the middle? The end?
Wait. No. The beginning.
The beginning? What do you think, Amani? You do it first. How do you know that? Oh. Let's see. Distribute first. So that's new for us, but we have to do this first. So everything else you can pretend doesn't exist. We have to distribute first. Here and here. So we've got 2x plus 10. And we haven't used any of this, so we just bring it to the next line. Does anyone have any questions on how that was done so far? Okay. So, So now we've got, again, complicated looking, but as you already know, it's not. So, what do we do at this point? Stephen? You said that beautifully. We got an x, and a 2x. What do we get when we add those together? 4x. Very good. 4x. And then we've got 5 and 10. And so we add those together. We got 15 equals 39. How many steps do we have left? How many steps do we have left, Cameron? 2. And so we can simply now solve. We draw our t. And it should be super quick for you at this point. You subtract 15. This cancels, and we get 4x equals 24. Divide both sides by 4. And you can easily see that x equals 6. So we get x equals 6, but we weren't asked to solve an equation for x. We were asked for the 3 numbers. So what are the 3 numbers? Well, x is 6, so the first number is 6. What's the second number going to be? Well, we put the 6 in here. 6 plus 5, what's the second number? 11. And what's the third number going to be? 22. So now our 3 numbers are 6, 11, and 22, and that is answering the question. So, comments and questions? Comments, questions? Alexis? Well, once we set up this equation, and we got 6 as the solution, then I plugged it back into each expression. The first number is x. X is 6, so the first number is 6. The second expression is x plus 5, so I put a 6 right here. 6 plus 5 is 11. 6 plus 5 is 11 times 2 is 22. Okay? Good. Good. So, now we've worked through some more challenging things. Now we're going to do the activity, and we've done this activity before. The activity where we switch roles. So, everyone draw a line across your paper and write classwork activity. Problem number 1.
You don't have to make it big, right?
So in the left column, you are the teacher. In the right column, you are going to be the student. We're not ready for the student column yet. We're going to be in the teacher column to begin with. You're going to be the teacher, I'm going to be the student. So I'm going to switch my hat around. I am now the student. You're switching your hat around, and you are now the teacher. You are going to watch your student do their work, and then you are going to be the teacher. So, I'm going to attempt to solve this complicated looking equation. I'm pretty confident in my ability, so I'm pretty sure I'm going to get it right. But if I by some chance get it wrong, you'll be there to guide me and to help me along. Okay? So, you can either write as I'm writing, or you can wait till I finish and then you can copy it down. And then I'm going to give you about 2.5 minutes to do your job as a teacher. Does anyone have any questions? Okay, I'm going to go ahead and solve this. I'm going to check real quick, make sure I got the right answer. Okay, I got the right answer. So, go ahead and you've got 2.5 minutes to be a teacher. So,
Wait, I can't.
You did a good job.
all right. I gave you some time to be a teacher, but it was kind of pointless because I'm going to prove to you that I got the right answer, and then we're going to move on to the next question. So, and I can prove it. So, x equals 1. So I plug the 1 right here and here. Okay, so I'm going to prove it. 1 minus 2 is 1. 2 times 1 is 2. Minus 9 is negative 7. 1 times negative 7 is negative 7. So I got the right answer. So I kind of tricked you into trying to analyze something that there were no mistakes on. So we're going to move on to the next question.
No.
And we're going to do this one. And then,
Go back, sir. Boy.
okay, I was just kidding. Hopefully you realize that there was a tremendous number of mistakes. So who would like to be the kind teacher to help out the student learn from their mistakes? So we'll start with Adriana, Essence, and then we'll go over to Nolly. Go ahead, Adriana.
Well, first, it was negative 2 times 2, so it would be x minus 4x. And
Let me see, hold on. So what, negative 2 times 2x. So this was supposed to be what?
negative,
This right here?
yeah.
Okay, so I see that, I think. Okay, that was a kind of a silly mistake. Okay, but I still got the right answer, so it's no big deal.
No.
Okay, go ahead.
And then it wasn't addition, it was multiplication, so it would have actually been minus negative 18, not negative.
No.
So I got negative 2 plus negative 9 is negative 11.
No,
No,
18. It's not multiplication, it's distributive propagation. I mean, it's not added, subtraction is multiplication.
Okay. So what is it supposed to be?
It's supposed to be
18.
So you're saying that's not right?
No.
Oh, okay.
It's also,
Okay. So Adriana, okay, I kind of see what you're saying. I think Essence, you were next.
yeah.
Well, you're already sort of explaining.
Also for the 4x, it's not 4x because it's a 1 in front of x. So it would be 5x.
Here, are you talking about?
Yes.
Well, yeah, this is nothing x plus 4x is 4x.
No, it's supposed to be a mini, a skinny Miss Cooper in front of the x.
Oh, I always forget the skinny Miss Cooper right there. Okay, so this was supposed to be 1 plus 4, so this is wrong too.
Yes.
Ah.
You're being more
Okay,
reasonable than last
Alright, I messed up a little bit. Okay, Nolly, what else? Is that it?
What?
No. Everything else is wrong.
Okay, but Nolly, I still got the right answer, right? So,
No. Can I just tell you what I got?
no, because we didn't do that yet.
Oh.
Okay, so I'll move on to Chelsea. Go ahead, Chelsea.
It would be x minus 4x because when you do negative 2 times 2, it comes out to be a negative, so it's negative 4x.
Okay, so it was like a mistake with another mistake. Then I compounded the mistake because I had made 2 mistakes in one line. Yeah, I made a lot of mistakes in that first line. Okay, well, I think I understand, and hopefully you listened to your classmates, and hopefully you confirmed what you already thought. And now you're going to have your chance to prove yourself. You've got a lot of the work done for you already, so you get a minute and a half to do it correctly. And then we'll see how we're doing. You got to rewrite the question in the student column. Now you are the student. Okay, so by the commotion and extensive amount of discussion, I can tell that everybody is done, although I have the people who are quietly working, so I'm going to be respectful of them. So we'll give another 30 seconds for them to finish up, even though part of my class is being a little bit disrespectful. I also have some of my students who worked through it, but then didn't do the teacher part for themselves. You did the teacher part for me, but then you didn't do it for yourself, and so you're missing part of the point. You have to be both now. All right, so let's see how we did. What is the correct answer to the question? Start with Annie, Chelsea, and then we'll go to Cameron M, and then Amani.
I got 2.2.
Okay? Okay. Okay. What is it? 2.2. So we have agreement with 2.2. Okay. So the correct answer. Nolly, you had something different?
Yeah.
What did you have?
Approximately
3.67. Okay. Tristan?
3.6.
3.6. That sounds similar to hers.
3.7.
3.7, which I'm assuming you rounded just like her. Okay. DeAndre?
I got negative 8.3.
Okay. So the correct answer is 8.3 repeating. Or 8 1/3. So that's what I was saying is you guys did a good job of being a teacher, but then you didn't do it for yourself. And so now you need to be the teacher for yourself. Because as far as I can tell, there's one person in the room who got it right. Who was the person who said 8.3? You said 8.3. Someone said negative 8.3, so I know what their mistake was, and that should be quick. But everybody else, you made some major errors.
I mean, sorry.
So now your job is to be the teacher for yourself. Find your own mistake. Because I'm going to ask you what your mistake was in a moment. So one of the mistakes was with distributive property and students not seeing that that is a negative 9. And one of your classmates was actually explaining this. This is negative 2 times 2x, that's negative 4x. But negative 2 times negative 9, what was I supposed to write right here? What was I supposed to write right here, Catalina? Plus 18.
Okay.
And now the x comes down, and then the negative 7 comes down. That was the correct first step. So the biggest mistake that I saw students making is putting negative 18 instead of positive 18. But that wasn't the only mistake. What's my next line supposed to be after I combine like terms? Chelsea?
Negative 3x plus 18 equals 7.
Negative 3x plus 18 equals negative 7. What about next? What's the next step? I'll help out. We draw our T. What's the next step here? Annabelle? Very good. Subtract 18 from both sides. Here was another mistake that students made. This cancels out. What do we get when we do negative 7 and negative 18? What do we get, George?
Negative 25.
You get negative 25. So, let me move this out of the way. Nope, that's not going to let me. So now I get negative 3x equals negative 25, and when I do that last step, I get x equals 8 1/3. Okay, so you guys did a pretty good job with the activity. Does anyone have any questions? Any other comments or questions? DeAndre?
Okay. For that, for the like terms, I think I actually forgot about the that's supposed to be a negative 3, so
What did you put?
for the answer I put negative 8.3.
So no, but here, what did you put here? You put positive 3?
Yes.
Okay. Do you see why it has to be negative? Very good. Kiara?
I just forgot to like multiply then
So you accidentally put a negative 9 here? Okay. Annie?
My mistake, I put negative 18. And also.
Here, originally? Good.
And also for the third line, I put 5x because I was looking at your example and I got mixed up.
Okay. Okay.
Yeah.
Okay, good. Draw a line across your paper. Your homework is page 128. You're going to do numbers 22 to 32 even And then you're going to do the brain game. The brain game is on.
And
The brain game is on the following page, 129, and you just have to read the instructions, and you'll be totally fine. And you have a quiz. I think I said you were having the quiz this week, but I was off by a day because I forgot we had yesterday off. So your quiz will be next Tuesday. That will be 3.1 to 3.3, and that will be next Tuesday.